Welcome to Chemistry for 10+2. Today we are going to understand the preparation methods of alcohols. The methods which we are going to see are, first is from alkenes, which is by hydroboration. Second, from carbonyl compounds by reduction. And third one, from Grignard reagent, that is hydration with mechanism, which we are going to see today. So let's begin with hydroboration of alkenes. Let's study the first method of preparation of alcohols from alkenes by hydroboration and oxidation. Diborane, that is BH3 twice, or you can say B2H6, reacts with alkenes to give trialkyl boranes, that is R3B, as the addition product, which is oxidized by hydrogen peroxide in the presence of aqueous sodium hydroxide to give alcohols. Let's see how the reaction is taking place. Here, the alkene which we are going to use is propene. 6 molecules of propene are used and it is treated with B2H6, that is diborane. We find the first product obtained is trialkyl borane. Let's understand how the reaction is taking place. As you can see here, boron gets attached over here and hydrogen gets bonded over here to form tripropyl borane. The product obtained is tripropyl borane, which is an addition product. This undergoes oxidation in the presence of H2O2, that is hydrogen peroxide, in alkaline medium. When oxidation is taking place, we find alcohol is obtained. So 3 molecules of N-propyl alcohol is obtained. So 3 CH3, CH2, CH2OH. Propan 1 all. And BOH thrice is the byproduct. So hydroboration and oxidation leads overall to hydration of an alkene. So this is how the reaction is taking place. The alcohol obtained is excellent yield. Here you can find the balanced reaction of hydroboration of propene. Propene undergoes hydroboration to give you tripropyl borane, and tripropyl borane on oxidation with hydrogen peroxide gives N-propyl alcohol or propan 1-ol. Let's see the next method of preparation, that is from carbonyl compounds by reduction. Aldehydes can be easily reduced to primary alcohols by undergoing catalytic hydrogenation. Let's understand it by a specific example. Here, ethanol is taken. Ethanol is nothing but acetaldehyde. When acetaldehyde undergoes hydrogenation in the presence of catalyst like nickel at 413 Kelvin, we find here the double bond is broken and one hydrogen moves to the carbon atom, whereas another hydrogen goes to oxygen atom. Thus, formation of alcohol is taking place and the alcohol obtained is primary alcohol. Here it is ethanol. Catalytic hydrogenation has been replaced by reduction with agents like sodium borohydrate, that is NaBH4, and LiAlH4, that is lithium aluminium hydride. By this method, that is catalytic hydrogenation, tertiary alcohol cannot be obtained. Hydrogenation can be carried out in the presence of catalysts such as finely divided nickel, which we have used in this reaction, or instead of this we can use platinum or palladium also. From carbonyl compounds, that is by reduction. Ketones can be easily reduced to secondary alcohols by undergoing catalytic hydrogenation. The ketone here used is propanol, that is acetone, plus H2 in the presence of catalyst nickel at 413 Kelvin. We can see here the double bond gets broken. One hydrogen moves to carbon atom and another moves to oxygen atom to form secondary alcohols. So ketones, when undergo reduction, forms secondary alcohols by catalytic hydrogenation. Tertiary alcohols cannot be obtained by this method. Hydrogenation is carried out in the presence of catalysts such as finely divided nickel, platinum or palladium. Sodium borohydrate is safe and easy to handle and can be used in water and alcohol also as the catalyst. Here, lithium aluminium hydride is more reactive than sodium borohydrate and reacts violently with water and alcohol. So, it is used with dry ether or tetrahydrofuran, THF. Let's talk about lithium aluminium hydride, LiAlH4. It is an expensive reagent, so used for preparing special chemicals only. Commercially, acids are reduced to alcohols by converting them to esters, followed by their reduction using hydrogen in the presence of catalyst. Here we have taken acetic acid CH3COOH. In the presence of lithium aluminium hydride H3O+, we find C double bond O gets converted to CH2 group and ethanol is obtained. Lithium aluminium hydride, being relatively more reactive than sodium borohydrate, is used to convert carboxylic acids to primary alcohols. On reduction, C double bond O group gets converted to CH2 group. Being more expensive reagent used for preparing special chemicals only, here esters are more easily reduced than carboxylic acids. So let's see the reaction how esters are more easily reduced than carboxylic acids. Here is the ester, ethyl propanoate. When it undergoes reduction using lithium aluminium hydride and H3O+, we find C double bond O gets converted to CH2 and this gives CH3, CH2, CH2OH. This is N-propyl alcohol, and in addition to this we get ethanol. that is C2H5OH. Ethyl propanoate, that is the ester, undergoes reduction due to lithium aluminium hydride to give two alcohol molecules. Here it is found N-propyl alcohol and ethanol. So two molecules of alcohols are formed from an ester molecule. The general reaction can be written as RCOOH, that is acid, gives RCOOR, that is ester, when it is treated with alcohol. And esters undergo catalytic hydrogenation to give two types of alcohols, RCH2OH and ROH. So here two molecules of alcohols are formed from ester molecules. Commercially, acids are reduced to alcohols by converting them to esters, followed by their reduction, that is catalytic hydrogenation. Let's see preparation of alcohols from Grignard reagent. As we all know, Grignard reagent is an organometallic compound. The formula is RMgX. Reaction of Grignard reagent with aldehydes and ketones gives alcohols. All the three types of alcohols, that is primary, secondary and tertiary, can be obtained by using Grignard reagent. Let's see the general reaction. Carbonyl compounds, maybe aldehyde or ketones, can be used. Here, Grignard reagent, that is RMgX. The reaction is taking place in the presence of dry ether. Alkyl group, that is R, carries partial negative charge as the electrons are moved slightly towards R, and MgX, that is Mg, carries partial positive charge. The double bond of carbonyl compound gets broken down to form the adduct, that is magnesium complex. In this way, the nucleophilic addition of Grignard reagent to the carbonyl group gives first magnesium complex, or we can say an adduct. This adduct undergoes hydrolysis in acidic medium to form alcohols, and MgXOH is the byproduct. All the three types of alcohols can be obtained by this method. Step 2 here, acid hydrolysis of magnesium complex yields an alcohol. Understand it by using specific example. Reaction of Grignard reagents with methanol gives alcohols. As we can see here, methanol, when treated with Grignard reagent, that is methyl magnesium iodide, in the presence of dry ether, it forms first magnesium complex, or we can say adduct. This adduct undergoes hydrolysis with dilute acid, giving corresponding alcohol. Here the alcohol obtained is ethanol, and MgIOH is the byproduct. Acid hydrolysis of the complex yield ethanol. Methanol produces primary alcohols containing one carbon atom more than in Grignard reagent. So here Grignard reagent contains only one carbon atom, whereas the alcohol obtained contains two carbon atoms. Let's see another example. Reaction of Grignard reagent with ethanol gives alcohols. Ethanol CH3CHO plus CH3MgI, that is methyl magnesium iodide, in the presence of dry ether first forms magnesium complex or adduct. This magnesium complex undergoes acid hydrolysis to form alcohols. Here, propan-2-ol is obtained, which is secondary alcohol, and MgIOH is the byproduct. Out of the two alkyl groups in the secondary alcohol, that is here, one is from aldehyde, that is this one, as it can be shown by the arrow, bonded to the carbonyl group, and other from the Grignard reagent, as it can be seen here. Acid hydrolysis of the complex yields propan-2-ol formation. Except methanol, all aldehydes produces secondary alcohols. Let's see the next example. Reaction of Grignard reagent with propanone gives alcohols. Here, this is propanone. When it is treated with methyl magnesium iodide in the presence of dry ether, formation of adduct is taking place, as it can be seen here. This complex undergoes acid hydrolysis to give 2-methyl propan-2-ol, and MgIOH is the byproduct. As it can be seen here, acid hydrolysis of this complex yields 2-methyl propan-2-ol. 2-methyl propan-2-ol is a tertiary alcohol. Out of the three alkyl groups in the tertiary alcohol, two are from the ketone bonded to carbonyl group, and the third from the Grignard reagent. Ketone produces tertiary alcohols. Different alcohols can be obtained by various combinations of alkyl groups in the carbonyl compound as well as Grignard reagent. Subscribe my channel, like it, and share it with your friends.